Let us begin with direct substitution. As x approaches 2, we can substitute 2 directly into the function. 4 plus 6 plus 1 gives 11. Therefore, the limit is 11.
Direct substitution gives 0 over 0, an indeterminate form. So we factor the numerator, cancel the common factor, and then take the limit. The answer is 4.
Here, direct substitution again gives 0 over 0. We remove the radical by multiplying by the conjugate. After simplification, the limit becomes 1 over the square root of x plus 1. At x equals 0, the answer is 1/2. One of the most important trigonometric limits is sin x divided by x as x approaches 0. Although direct substitution gives 0 over 0, the fundamental trigonometric limit tells us that the value is 1. Consider sin 5x divided by x. We rewrite the expression by multiplying and dividing by 5. This gives 5 times sin 5x divided by 5x. Using the standard trigonometric limit, the answer is 5. Another important limit involves the exponential function. As x approaches 0, e to the x minus 1 divided by x approaches 1. This standard limit is closely connected to the derivative of e to the x. Now consider 1 divided by x squared as x approaches 0. Closer to 0 from either side, x squared becomes very small and it'll becomes extremely large. Therefore, the limit tends to infinity. For 1 over x, the behavior is different on each side. Approaching 0 from the right gives positive infinity, while approaching from the left gives negative infinity. Since the two sides disagree, the two-sided limit does not exist. For a limit at infinity, divide every term by the highest power of x. As x becomes very large, 1 over x approaches 0. The expression therefore approaches 2. We have seen several important methods for evaluating limits. Infinite limits at infinity. Choosing the correct method makes difficult-looking limits much easier to solve.